right. Back one more time, just to give a quick rundown of the Chapter 11 test and the things that you can expect to see and kind of the homeworks that are due and things like that. So as you can see here on the right side, all the homeworks that are going to be collected with Chapter 11 are listed on the right side there. Left side are some characteristics about the test, 40 points total, 11 multiple choice, 4 short answer. 13 of the questions are 2 points each, and then there are 2 7-pointers. So that makes up a big chunk of the test. So I just wanted to hit on, again, some of the big picture stuff. This was section 11.1 when we talked about all the different ways to count, right? We have the fundamental counting principle, which means you can repeat values, or you're choosing, you're making a decision based on multiple different categories, such as license plates, outfits, and sandwiches were some of the examples that we covered. So that was, the FCP is kind of the one-off, the weird one, where there's no formula for it. You just kind of like, right, you do the slots and then you fill in your options for each one and just multiply. And then the last two are permutation and combination, right? And then for both of those, you cannot repeat a value. That's if you're choosing if you're choosing a number of items from a large pool, then you have either a permutation or a combination. Again, the big difference is a permutation order matters, a combination order does not. Okay? So a permutation, we kind of think of like arranging items, books on a shelf, gold, silver, bronze medals if you're handing that out at a race, or president, VP, and secretary. Something that assigns different roles or different responsibilities would be an example of a permutation, or we would use a permutation in order to count the number of possibilities. And then in a combination, the order does not matter. So how many ways can you receive a hand of cards? It doesn't matter in which order you receive the cards. What if you're only advancing to the next round in a race or a competition? And what if you're selecting a committee of people, assuming that each person has a shared role and there's no differentiation between them. So that was kind of 11.1. Then we moved to actual probability in 11.2. We talked about experimental versus theoretical, right? Experimental probability actually occurs. It is based on events that you've tried or seen happen. And again, all these are written as a fraction. The number of times an event occurred is your numerator, divided by the number of trials makes up your probability, makes up experimental probability, I should say. Similarly, the theoretical probability is calculated without actually having done the action. So the probability of an event is the number of outcomes that match the event, also called the event space, divided by the number of possible outcomes, which is the sample space. Okay, so this was 11.2. We just talked about theoretical probability versus experimental and did a little bit with each one of those. So then in 11.3 we talked about independent versus dependent events. So independent events occur separate from one another and have no bearing on one another. This is like the rolling a die and flipping a coin. It doesn't matter how the coin lands, that's not going to affect the die roll in any way, shape, or form. Whereas dependent events would be one occurring does affect the other one. So if I, the classic example is, well, what happens what's the probability it's going to rain tomorrow? And how does that affect the probability that a sports game is canceled? Obviously, those are in line, because if it rains, then you have a higher probability of cancellation, whatever. A couple formulas came out of 11.3. It was, remember we learned these two new symbols. We have the upside down U is and the right side up U is or. They technically are the intersection and the union, respectively, but whatever. So if A and B are independent events, to find the and probabilities, you multiply. So that's a big thing to remember, is that if you see the word and, you're most likely going to be multiplying together. And then whether they are independent or not, the probability of A or B. So what's the probability that either event A or event B happens? Is the probability of A plus the probability of B. So or means you're going to add. But then we have to subtract off the overlap because we don't want to double count. This is the music. Do you play a musical instrument or do you play a sport question, right? Where someone could say yes to both and then you're double counting them, and that's not a true probability. And then finally, we said if two events are mutually exclusive, that means they cannot occur simultaneously, which means the probability of A and B equals 0. So if things are mutually exclusive, they cannot occur simultaneously. So that was, again, we did like so in 11.3, we talked a little bit about replacement versus without replacement, and that led into conditional probability in 11.4. So remember, conditional probability is all about given events. So what is the probability of event B occurring given that event A has already occurred? So you know something has happened. How does that change, or what does that do to the probability of event B? Okay. The key with this is that the given event affects your sample space, okay, or the possible outcomes. So when you're talking given this, that means your sample space is shrinking most times, and then you are changing the probability. You are changing the probability from there. And this is where we had these two-way tables where we added on the totals. Right, total. So 150 is the total number of people who do play a sport. 350 is the total number of people who don't play a sport, which gives us a grand total of 500 people who have answered this survey. And then if we go the other way straight across, we have 200 people who said yes to do you play an instrument, and 300 people who do not play an instrument. So again, we double check and see that that's 500 total. And then we just did some probability questions with this. So if I said, what's the probability of choosing a person at random who plays a sport? The key is that that's talking about all 500 people. So that would be your sample space is 500. And then if it just says someone who plays a sport, I would look at that total number. So that would be 150 over 500. Whereas if I said, what's the probability of someone playing a sport given that they play an instrument? What that changes is that I know that they play an instrument, so I'm only talking about this set of 200 people, right? So my sample space has shrunk from 500 down to 200, and then it's what's the probability they play a sport? It would be 50 out of 200, or 1/4. So that's kind of the stuff that we did in 11.4. We also did a tree diagram. I'm going to run through another example of this just to give just more exposure to these tree problems. And this goes back to what we were talking about earlier. Say there's a 60% chance of rain today. If it rains, the probability that the baseball game is canceled is 0.8. If it doesn't rain, the probability of the game being canceled is 0.1. So there's a 60% chance of rain. So we have rain or no rain. Oh boy. We have rain or no rain. This was 0.6, which means that the no rain option is 40% chance. So we have canceled or not canceled. I'm going to try to be crafty with technology. We'll see how this goes. Okay, so we have canceled or not canceled. The problem says if it rains, the cancellation is an 80% chance. This is 0.8, which means this is 0.20. And then it also said if there's no rain, the cancellation goes down to 10%, so 0.10 and 0.90. Okay, so there's our tree diagram. What is the probability that there is rain and the game is played? Again, just kind of like what we talked about, and it's no different here. If you see the word and in a tree diagram, you're going to have to multiply those individual branches together. So there's a 60% chance of rain, so 0.60 multiplied by the game is played, meaning it's not canceled, so that'd be 0.20. Multiply those together, and I get 0.12. So there's a 12% chance that that there's rain and the game is played. And then what's the probability that the game is canceled? And again, with tree diagrams, it's tough because it's actually the less information about the event, the more difficult or the more work we have to put in. So what's the probability the game is canceled is both that branch of this tree diagram as well as this branch. Oops, sorry. Not that one. We want the probability that it is canceled, so we have to calculate that branch as well as the no rain but canceled branch. Okay, so we would have to do 0.6 multiplied by 0.8 and add that to 0.4 times 0.1. Okay, now if I come over here, this is 0.48 plus 0.04. So there's a 52% chance of that game being canceled, regardless of weather. So 52% chance. Nope, don't want that. Okay, so there is our tree diagram from 11.4. And then we wrapped it up with 11.6, which was box plots. We have three ways to measure the center of a data set. There's the mean, which is also known as X bar in the calculator. There is the median, which only has its own little abbreviation, MED. And then there's the mode, which is the value that shows up the most often. And then we looked at box plots to summarize some data. So in the box plot, we have the minimum value at the end, which in this case looks like 2. Then we have what's called the first quartile, looks like 5. We have the median, is that center line of the box, looks like 6. We have the third quartile, which is 9. And then we have the maximum value, which is 14. Okay, and then the last three characteristics that we talked about from a data set are the range, which is the max minus the min. So how far apart are the highest and lowest values? We have the inner quartile range, or the IQR, which is Q3 minus Q1. And then we have the standard deviation, which we're not going to talk about how to hand calculate it, but you enter your data into L1, stat, calc, one variable stats. Remember, standard deviation is like the sigma x, and that's a value that gives roughly how spread out a data set is. So that was 11.6, analyzing data using box plots. Again, those are the homeworks that we have and some of the test characteristics. Make sure you're studying so we can knock it out the park.